If you look at a graphic like this, many people would attempt to draw it in a very particular way that in most cases would be an inefficient use of the time. So if we just consider here the boundaries between the different colored elements, typically people would look at that as a challenge to create not just the figure elements that you're seeing here, but also the background elements. And so what that would mean is that they would draw in this fashion, sort of like the pieces of a jigsaw puzzle. Now the problem with approaching it in that way is that, first of all, accuracy, the chances of you being able to render both sides of that shared boundary are incredibly slim. And as you can see here, there are slight variances in the curvature causing some gaps. Now there are ways around that in which you could copy pieces of one boundary and incorporate them into use in the second shared boundary. However, it's really grossly inefficient. So drawing mutual boundaries on both sides, you're really creating twice as much work. So there's another way of doing that. And if we look at this, it looks essentially the same as what we saw before. However, this takes advantage of layering, and then taking advantage of layering, you are able to only have to draw one common border. So I'm just going to move this green piece, and you'll see exactly what I mean. So as I move this out of here, you'll see that it's that green piece, the very top layered object, which gives definition to those objects whose boundaries are mutually shared. So two very different approaches. This one that we're looking at here, taking advantage of the layering, creates half the amount of work as this approach does. So think about that when you're approaching your next drawing project. How might you use layering to cut your workload in half where common boundaries are concerned?